In this video, we're going to look at modeling a linear function. And we're going to look at actually at the first problem from your practice set in section 1.2. In this problem, it says a skateboard park charges $7 per session to skate and $4 per session to rent safety equipment. Jared skates safely and rents safety equipment every time he skates. He also bought a new skateboard for $125. Alright, so part A asks us to write an equation that can be used to find the number of sessions Jared attended. So there's a couple things going on here. Not only did he spend $125 on a new skateboard, there's two other things that he's paying for every skate session. There's $7 for the park, and there's $4 to rent safety equipment. Okay, so for part A, the costs would be, and we're going to denote our function f of s. Okay, this is also the same thing as writing y equals. This is just called function notation. We're going to be using it throughout this unit. So here's our costs. We know that for every skate session, there's going to be $7 cost to go to the park. Plus, there's going to be a $4 cost for the rental of safety equipment. And then there's also, on the year, Jared also bought a $125 skateboard. That's the fixed cost. So the only thing that changes here are the number of, the cost Jared accrues for the sessions at the skate park, which would be the $7 and the $4. So because they're going to be charging for every skate session, we can combine these. These are like terms. So 7 plus 4 would give me 11 S's plus $125 that he spent on a skateboard. Alright, and there's our equation that represents the amount of money that he spent after a certain number of sessions. Part B, if your function is denoted with f of s, which we've already done, where s is the number of sessions, which we're representing s as the number of sessions. Determine f of 3. That's the f of 3. Where 3 represents s, which is the number of sessions. Alright, so if we have 3 sessions, how much is it going to cost him? That's what it's asking. And then f of s equals 235. Well, here we don't know the number of sessions. And what we would know is that the cost is going to be $235. So we're looking for the number of sessions it's going to take him. So for part B, we're going to determine f of 3 first, which means we're going to input 3 into our function. So it would be 11 times 3 plus 125. So this is going to come out to be 33 plus 125, which would be 158. Okay, and we can interpret this as after 3 skate sessions, it has cost Jared $158. Now for f of s equals 235. This means that I know my final cost. So I know that my function 11s plus $125 is going to equal a total of $235. How many skate sessions is that going to be? So subtracting 125 from both sides is going to be the first step in solving my linear equation. And I'm left with 11s on the left side. And on the right side, we're going to have 110. So undo my multiplication by dividing by 11. We get s equals 10. So I can interpret that now as it has cost $235 for 10 skate sessions. Alright, so we've now finished B. We've interpreted our meaning of both of the f of 3 and f of s equals 235. That's function notation. So now for part C, we're going to determine our x and y intercepts and place them on a graph. and then we're going to interpret what they mean. And really, do they make sense? Okay, so here's what we have to know for x and y intercepts. For every x-intercept, what's true for the coordinate is that y is going to equal 0. And then also, for the y-intercept, the x-coordinate is always equal to 0. So we're going to use those inputs to actually solve for the x-intercept and y-intercept. So if for the x-intercept first, if the y value is equal to 0, meaning the output is 0, meaning in this case, my cost is 0. So if 0 equals 11s plus 125. If I subtract 125 from both sides, I would get 11s equals negative 125. If I divide by 11 to both sides, I'll get negative, let's see, negative 125 divided by 11 will be approximately, not equal to, approximate, so that's going to make my equal sign turn a little squiggly here. That means that's the approximate symbol. Negative 11 point, we'll say 4. Alright, so it's going to be an x value of a negative 11.4, comma, a y value of 0. So this is number of skate sessions. This is my cost, f of s. So it says, after negative 11.4 skate sessions, my cost is $0. This makes absolutely no sense because you can't have negative 11 or negative anything for skate sessions. So we would say my x-intercept is not relevant to my story. It does not make sense. Now for the y-intercept, we're going to let x equal 0. So I want to know f of 0 for my function. So I'm going to plug x into my function. So 11 times 0 is going to be plus 125. 11 times 0 is 0. So we're just left with 125. So my coordinate is going to be x value of 0, y value of 125. Once again, 0 is the skate sessions, 125 is my cost. So I can interpret this as, after not skating at all, Jared spent $125, which makes sense because he bought a new skateboard. No matter if he skated or not, he still spent money on skateboarding. And for part D, I'm going to squeeze that in right here. For part D, it asks, what is the slope of your linear function and what does it mean? So the slope here is going to be 11. And what that means is that for every skate session, it's going to cost Jared $11. And when you're interpreting the slope, you have to take into account both the input and the output. So there's two things we're considering here. We're looking at skate sessions and cost. Right? So if we put this as rise over run, it's $11 per one skate session. All right, and that is your tutorial of modeling linear functions. The only thing we didn't do here is roughly graph a sketch in part C. And I'm going to leave that up to you to draw those coordinates and make your line. And maybe that will also help you interpret whether it makes sense in relation to the story. Good luck.